Hi, it's Jack Kaluki from Nitrix, and I'll explain why process control improves not only the quality of your end product, but also helps save money while reducing pollution. Nitriding and nitrocarburizing processes derive from the same catalytic reaction where ammonia dissociates and atomic nitrogen is absorbed into steel and iron surfaces. The essential question is how much nitrogen is necessary and how to control the process. Until the introduction of the two-stage flow process, nitriding was done using fixed flows. At the start of the process, the flow of ammonia provides a source of nitrogen necessary to create a compound layer or white layer. However, if one continues the process for too long to obtain a deeper case or a thicker diffusion layer, this flow becomes excessive. Nitrogen starts piling up on the surface, creating a thick, brittle white layer without mechanical properties. It has to be removed or ground away. The two-stage flow process introduces a second stage with lower flows or atmosphere diluted to reduce the quantity of nitrogen. It's still possible to further improve the process by analyzing the exhaust gas and seeing how much ammonia it contains using a burette or a gas analyzer. This will allow to fine-tune the process, creating a control loop. But how do we know the exact nitriding potential or dissociation level necessary for each step of the process? Early on, scientists such as Lehrer and Frey had introduced iron-nitrogen diagrams showing boundaries of different phases in function of temperature and nitriding potential. These diagrams are helpful in creating a recipe aiming at a specific thickness of white layer, case depth, or diffusion layer by providing a nitriding potential to use as a reference for each process stage. Once automated, the control loop adjusts the flow of ammonia to the thermochemical reaction taking place in the furnace depending on the total surface of the components, the surface of the furnace as well as the fixturing. It allows to increase or decrease the usage of ammonia. If necessary, it dilutes the atmosphere even more to adjust to the conditions inside the furnace. Therefore, one can use strictly the amount needed to reach the specification by adjusting the reaction in the furnace, never resorting to fixed or excessive flows. The specification is reached time and time again, regardless of the number of parts in the furnace. This is achieved without overshooting or excess ammonia flows to reach the target. There are several advantages related to automatic process control. One of them is the high repetition of results, or high CPK in statistical terms. The second advantage is lowest possible consumption of ammonia, of course, and finally, the lowest possible emissions and resulting pollution. Those three factors are behind the success and continuous growth of controlled gas nitriding and its applications in the industry. Click on the screen right now to watch another video on nitriding and nitrocarburizing. Make sure to leave a like or a comment and subscribe to our channel. Thank you for watching and see you again in next video.